Hello, my dear students and the rest of the learners. Welcome to part 25 of a 7-part series of tutorials in computer structured programming in C and Pascal. This is section 4 of 13 in the topic data structures. My name is MemJM, or you can simply call me EMELISWAP. In this tutorial, I'm going to look at the data structure that is called arrays, under which I'll look at the meaning of arrays or introduction to arrays, one-dimensional array, also called vector, multidimensional arrays, how to refer to an array element, how to implement arrays in C and Pascal, and lastly, I'll look at passing of arrays to functions. Let's commence by looking at the introduction to arrays. An array is a group of memory locations that stores a list of data values of the same type and with the same name. This list of data values forms a vector, a table, or a matrix with one or more columns of data. The elements in an array are known as array elements. Arrays are useful when the number of elements to be stored is fixed. They are easy to traverse, search, and sort. Arrays are static entities in that they remain the same size throughout program execution. So, when an array is declared to have a certain number of elements, the compiler reserves the required space in memory. This allocation is based on the information available at compilation time. This type of allocation is called static allocation. The disadvantage with the static allocation is that if the number of elements entered are less than those in the declaration, that is, those reserved for allocation, the extra space that has been allocated is wasted because it can't be assigned to any other variable. The two main categories or types of arrays are therefore one-dimensional array and multidimensional arrays. An array type is defined by the number of subscripts. That is the number of rows and the number of columns that it has. In other words, the number of dimensions. An array declaration indicates the data type of each element, the name of the memory to be occupied by the array, and the number of elements required by each array so that the computer may resolve the appropriate amount of memory. In a declaration, one can be able to tell whether an array is a one-dimensional or a two-dimensional array or three-dimensional array, etc., depending on the number of subscripts in that array. For example, if an array declaration had one subscript, then it becomes a one-dimensional array. But if it has two subscripts, then it becomes a two-dimensional array, etc. Let's look at one-dimensional array, also called vector. This is an array composed of only one row, but with many columns, or many rows, but with one column. For example, if you want to store the scores attained by a single student in 7 exams as an array, then this will be a one-dimensional array. Elements in an array can be stored in any of the following two ways. One is what we call the row manger, and the other one is column manger. The following is therefore an array called scores that has 7 elements stored in row manger. So these are our 7 elements or our 7 scores: 90, 40, 20, 90, 100, 15, and 45. These are 7 elements in our array that is called scores. These values have been stored in row major. All of them, the 7 elements, are in the same row, that is row 1, but each value is occupying a specific column. So in row 1, column 1, we have 90. Row 2, column 1, we have, in other ones, let me repeat. In this array, we have 7 elements. Each element is occupying a specific column, but all of them are in the same row. For example, in column 1, row 1, or row 1, column 1, we have 90. Row 1, column 2, we have 40. Row 1, column 3, we have 20. Row 1, column 4, we have 90. Row 1, column 5, we have 100. Row 1, column 6, we have 15. And row 1, column 7, we have 45. And therefore, the scores have been stored in row major order as row 1, column 1, row 1, column 2, row 1, column 3, row 1, column 4, row 1, column 5, row 1, column 6, and row 1, column 7. Whereby row 1, column 1 refers to element 90. Row 1, column 2 refers to the element 40. Row 1, column 3 refers to the element 20. Row 1, column 4 refers to element 90. Row 1, column 5 refers to element 100. Row 1, column 6 refers to element 15. And row 1, column 7 refers to element 45. The other method of storing or of referring to elements in an array is what we call the column major, whereby all the elements are occupying or assigned to the same column. In this case, column 1. And therefore, what changes are the rows. For example, 90 is in row 1, 40, row 2, 20, row 3, 90, row 4, 100, row 5, 15, row 6, and 45, row 7. This means that the scores have been stored in column major as row 1, column 1, row 2, column 1, row 3, column 1, row 4, column 1, row 5, column 1, row 6, column 1, and row 7, column 1. Therefore, the column is not changing for the 7 elements, whereby row 1, column 1 refers to 90, row 2, column 1 refers to 40, row 3, column 1 refers to 20, row 4, column 1 refers to 90, row 5, column 1 refers to 100, row 6, column 1 refers to 15, and row 7, column 1 refers to 45. The syntax of declaring a one-dimensional array in Pascal is var array name colon array. Then we have x to y enclosed in square brackets of array type, where array name is the name of the array. The subscript x to y are the limits which imply that the first element of the array will be denoted by subscript x, while the last element is denoted by subscript y. Subscript x and subscript y simply refers to the first subscript for the first element, and y refers to the last subscript for the last element. For example, the array that I have already illustrated can be declared as var scores, the array name is scores, then array 1 to 7 of integer. While the syntax for declaring a one-dimensional array in C is data type, then array name, and we enclose the size in square brackets. For example, in this scores 7, the array name here is scores, the data type is int, and the size of this array is 7. The size of the array is calculated as x minus y plus 1. Let's look at multidimensional arrays. These are arrays that are used to represent objects or scenarios with many views or dimensions and is composed of data elements or data, also referred to as elements, arranged in several rows and columns. The number of rows and columns is identified using the relevant subscripts or indices, and their elements are manipulated just as it is for the one-dimensional arrays. These can be two-dimensional, three-dimensional, etc. For example, if you want to store scores attained by 2 students in 7 exams each, then this array automatically becomes a two-dimensional array because one dimension represents the number of students sitting for similar exams, and the second dimension represents the number of exams, that is, scores attained in the 7 exams by each student. This array can therefore be represented as follows, where we have our elements spanning from column 1 to column 7 and row 1 to row 2, whereby the elements indicated in the columns represent the scores attained, while the rows, that is scores in the first row and the scores in row 2, simply refers to the scores attained by the students. And therefore, row 1 is for the first student and row 2 is for the second student. In this case, each row represents a student and each column represents the scores that each student attained in the 7 exams. And therefore, it indicates 2 rows and 7 columns. The elements in the above array can be stored in either row major order or a column major order as follows. When we look at or when we refer to the elements or when we store the elements in a row major order, we begin by referring to the elements in the first row, and then once we complete the last element, we move on to the elements of the second row from the first to the last. And therefore, in the row major order, we have row 1, column 1, row 1, column 2, row 1, column 3, row 1, column 4, row 1, column 5, row 1, column 6, row 1, column 7, then row 2, column 1, row 2, column 2, row 2, column 3, row 2, column 4, row 2, column 5, row 2, column 6, and row 2, column 7, whereby row 1, column 1 refers to 90, row 1, column 2 refers to 40, row 1, column 3 refers to 20, row 1, column 4 refers to 90, row 1, column 5 refers to 100, row 1, column 6 refers to 15, row 1, column 7 refers to 45, row 2, column 1 refers to 60, row 2, column 2 refers to 45, row 2, column 3 refers to 80, row 2, column 4 refers to 76, row 2, column 5 refers to 55, row 2, column 6 refers to 18, and row 2, column 7 refers to 100. When we look at the storage of the elements in column major order, we begin with row 1, column 1, row 2, column 1, row 1, column 2, row 2, column 2, row 1, column 3, row 2, column 3, row 1, column 4, row 2, column 4, row 1, column 5, row 2, column 2, row column 5, row 1, column 6, row 2, column 6, row 1, column 7, and row 2, column 7. So we complete the items for each column and then we move on to the next column, whereby row 1, column 1 refers to 90, row 2, column 1 refers to 60, row 1, column 2 refers to 40, row 2, column 2 refers to 45, row 1, column 3 refers to 20, row 2, column 3 refers to 80, row 1, column 4 refers to 90, row 2, column 4 refers to 76, row 1, column 5 refers to 100, row 2, column 5 refers to 55, row 1, column 6 refers to 15, row 2, column 6 refers to 18, row 1, column 7 refers to 45, and row 2, column 7 refers to 100. The above array is of order 2 by 7 because it has 2 rows and 7 columns. Therefore, it's a 2 by 7 multidimensional array. The order of a 2-dimensional array is denoted by m by n, where m is the number of rows and n is the number of columns. So, the number of rows and the columns of an array, that is in a matrix or 2D, defines its order. And the number of indices that an array declaration has determines the type of the array. The number of elements in a 2-dimensional array is y1 minus x1 plus 1 multiplied by y2 minus x2 plus 1, while those for a 3-dimensional array is y1 minus x1 plus 1 multiplied by y2 minus x2 plus 1 multiplied by y3 minus x3 plus 1, etc. The syntax for defining a 2-dimensional array in C is as follows. We have data type, array name, the size of the row, and the size of column, each of them enclosed in square brackets. For example, int performance 2 by 7, where 2 is the size of the row and 7 is the size of the column. While the syntax for a 3-dimensional array is data type, array name, then number of 2D or 2 dimensions, number of rows, and number of columns. For example, if we want to store the performance of 4 schools in 7 exams for 3 students each, then this can be a 3-dimensional array whose first dimension represents schools, second dimension represents exams, and third dimension represents students. This array can be declared as follows in C. The array name is performance. It has 3 dimensions, 4 for the schools, 7 for the number of exams, and 3 for the number of students per school. The array type or the data type is integer. In Pascal, the syntax for declaring a multidimensional array is as follows. Array name, then array, then in square brackets, we indicate the subscripts for each dimension, where we have x1 to y1, comma, x2 to y2, comma, all the way to xn to yn of array type. For example, the array name is performance. The array has 2 dimensions, where we have the first dimension being 1 to 4, and second dimension being 1 to 7 of integer, and therefore this statement or this declaration is for a 2-dimensional array. For a 3-dimensional array, we can have performance array 1 to 2, comma, 1 to 7, comma, 1 to 3 of integer. Note, the subscripts are all enclosed in square brackets, and their separation is using commas for dimensions. So this is a 3-dimensional array. How do we refer to an array element? When referring to a particular location or element in an array, we specify the name of the array and the position number or index, or what we call subscript, of that particular element in the array, while starting with the subscript of the row, then the column if the element is stored in a multidimensional array. Once an array has been declared, each of the elements are assigned subscripts starting with 0 by default. Therefore, if a 1-dimensional array, for example, underscores is declared, its elements will be subscripted as follows. So, in our array for 7 elements, 90 will be subscript 0, 40 subscript 1, 20 subscript 2, 90 subscript 3, 100 subscript 4, 15 subscript 5, 45 subscript 6. And those are also called indices. So we have indices running from 0 to 6, what I'm calling subscripts. In this case, the compiler references an element in the array with the array name and then the element's subscript. For example, to refer to 100 in the array called scores, it will be done as follows. It is scores subscript 4. While to refer to value 15, it will be scores subscript 5 or indices 5. This also means that we can assign a new value to the array. For example, we can replace value 20 with the 60 as follows in C. 60 assign 2, subscript 2 in the array called scores. That is in C. Or we can do the same as 60 assigned to subscript 2 in the array scores. The only difference between the way we assign in C and in Pascal is the assignment operator. We can also perform other operations with elements in the array by defining each element with its subscript. For example, we can add the element in subscript 6 of the array to the element in subscript 0 of the array, and the sum, we assign it to a memory location called D. So this is how we do it in C. If it's a two-dimensional array, we indicate an element's two subscripts, one for the row and the other for the column. For example, the following will be representation of performance array. So we can have 90 to 45 for row 1 being indicated by index 0 or subscript 0, while the elements spanning from 60 to 100 for row 2 is represented by index 1. While on the side of the columns, column 1 is subscript 0, or column 2 subscript 1, column 3 subscript 2, column 4 subscript 3, column 5 subscript 4, column 5 or column 6 subscript 5, and column 7 subscript 6. So 0 to 6 are the column index, while 0 to 1 are the row index, or index or subscripts for the row is 0 to 1. Subscripts for the column is 0 to 6. In this case, we can refer to element, for example, 76 as array name performance, what is in subscript 1, column subscript 3. So 1 and 3 represents the subscripts or the indices. So we are referring to the content of subscript 1 for the row and 3 for the column being 76. In Pascal, while in C, we just do the same, but we enclose each subscript in square bracket. Therefore, the formula for getting the appropriate subscript of a one-dimensional array is array name I minus 1, whereby I is the element number, e.g., subscript for the first element in the array called scores can be done as scores 1 minus 1, which becomes scores 0. The fourth element subscript, in this case, will be scores 4 minus 1, which becomes scores 3. In other words, 3 in this array called scores refers to the element in the array, which is element number 4, whose subscript is 3, because the subscripts or the indices range from 0 to the maximum or to the highest. Well, the formula for getting the appropriate element subscript in a two-dimensional array is array name I minus 1, then j minus 1 for the column in C, and array name I minus 1, comma, j minus 1 in Pascal, whereby I is the element's row number and j is the element's column number. For example, the subscript for the first student's then the score in the array called the performance is 20, or that is 20, will be performance I or 1, 1 minus 1, then 3 minus 1 for the column in C. And the performance, square bracket, 1 minus 1, comma, 3 minus 1, square bracket in Pascal, which becomes performance 0, subscript 0 for the row and subscript 2 for the column. And the performance subscript 0, comma, 2, respectively. So, my dear students and the rest of the learners, kindly note that the subscript does not directly translate to the element number. Subscript 0 will refer to element 1. In other words, to know the element number in the array, you get the subscript and 1. For example, the first element in the array whose subscript is 0 will be gotten by saying 0 plus 1. So 1 is the first element. Once we are able to determine the correct subscript for each element in a multidimensional array, we can manipulate each element as if it were just, or as if we are just handling a value. For example, to compute the sum of 20 and 76 from the performance array and assign the result in a variable called results, we can do it as follows in C. We have the element stored in subscript 1 for the row, 3 for the column in the array called performance, and then 2, the element in the array called performance, which is at 0, subscript 0 for the row and 2 for the column. The total, we assign it to the memory location called result, that is in C. When in Pascal, it can be done as follows. Pick the item or the element in the array called performance at subscript 1 for the row, column 3, or 3 for the column, and then 2, the element in the array called performance whose index or subscript is 0 for the row and 2 for the column. And the results, we assign them to the memory location called result. The difference between the two is how we write the subscripts for the array and the assignment operator. The entire array cannot be manipulated using a single statement, and therefore, array elements are usually manipulated one at a time inside a loop that iterates many times. The most commonly used control structure to manipulate elements of an array is the for loop. How do we then implement arrays? How do we implement one-dimensional array? The following is a C program that prompts the user for cuts and exam scores for a student in 7 subjects. The program then displays the scores entered, computes and displays the student's average score per subject, overall total score, and the student's mini score. So as usual, we have the comment. And then we have preprocessed directive for the standard input-output file, that is stdio.h. And then we define a constant which is called total, and it's of size 7. Then we have our major function main, and then we declare a memory location for an array called the cuts, and we initialize all the elements in this array with 0 or to 0. So we have int cuts. The subscript is total equals to all the elements initialized to 0. In other words, this statement declares a memory location for array called the cuts and initializes all the elements into 8 to 0. Then we have another array called exams. And it has 7 elements. So the array for exam scores, int exams, array size is 7. Then we have another array called averages, which is of size 7, and it will contain elements of type double. So it is array for cards and exam averages. Then we have a variable called sum that is going to hold the total for the student. Then we have another memory location called miniscore, which is of type double. It will hold the miniscore for all the subjects. Then we have a variable called I, which in this case we shall use as our counter. Then the next statement is to prompt the user for CAT scores in 7 subjects. We display the message, enter CAT scores for the 7 subjects. We drop down one line, and then we read. We assign 0 to I. Then we check if the value in the memory location called the total is less than the content in memory location called I. Once we check if the content of memory location called I is less than total, then we display subjects. That is, for example, subject number 1. That is, we pick what is in the memory location called I. Of course, we initialize to 0 and 1. So that will be subject 1. And then we read the first CAT for that subject. We store it in memory location called CATs. And then once we do that, we increment the content of I with 1. So we move to 2. And then we check, is 2 less than total? Remember, total is 7. So is 2 less than 7? Yes. So we repeat. We display the next value, that is subject. Content of I and 1. So 1 plus 1, that is 2. So subject 2. And then the user will enter the next value or the next value for CAT. It will be read and stored in memory location called CATs. That is CAT, that array subscript or that possession. And then we increment the value of I. If it was 2, it will now be 2 plus 1, which is 3. Then we check whether 3 is less than total. 3 is less than 7, which is true. If that is true, we then display subject. We display the subject number. And that will continue, my dear students, until the value of I is not less than total. It's not less than 7. And once the value of I exists or is not less than total, we are going to exit from the loop. And by that time, we shall have entered all the CAT scores for the 7 subjects. And then we prompt for exam scores in the 7 subjects. So we request this person to enter exam scores for the 7 subjects, where we also do the same. We initialize the value of I to 0. And then we check whether the value of I is less than 7. So is 0 less than 7? If it is true, then we display the subject. So which subject? Subject, the content of I plus 1. I initially is 0, so 0 plus 1. And therefore, this statement will display subject 0 plus 1, that is subject 1. Then the user will enter the score for the first subject. It will be picked and be stored in memory location called exams at I or subscript I. And then the counter will increment the value of I with 1. So if I was 1, it will be 1 plus 1, that is 2. Is 2 less than 7? Yes. Therefore, request for the second subject's score. The user will enter second subject's score. It will be stored at the second position in the array. And then that will continue. The loop will continue until the value of I is no longer less than 7. And therefore, that loop will end. The 7 subjects will have been entered. And therefore, the next statement will be the following are the scores for cards and exams in the 7 subjects. So we are going to display the 7 subjects, whereby this for loop will be used to output the values as stored in the array that we are having. And therefore, this statement will display each value spaced 5 characters or with a space of 5 characters. This statement picks the content of the array called cards at the first subscript, displays it, then goes back again, increments the value of counter, that is I with 1, then displays the next element at the next subscript. And that will continue until the value of I is not less than total, and the loop will end. And then this printf here is going to display the double quotes and move 1 line below. And then next is printf exams. This statement will display, or this statement informs the user that we are about to output the scores attained in the 7 subjects. And therefore, we use the for loop. For I equals 0, I less than total. Then increment I. Remember, we initialize 0 or I to 0. Then we check the condition. Is the value of I less than total? If yes, if it is less than total, we execute this statement here by picking the content of memory location called exam as subscript I. We print it out. Then we increment the value of counter I plus plus. We increment with 1. We then check the condition. Is the current value of I less than total? Yes. So we move on. We display the next value in the memory location called exams as subscript I, and formatted 5 spaces. And that will continue until all the elements of the array are displayed or output. And then we drop down 1 line. From there, this part computes the average for each subject. So initialize sum to 0.0. And then we use the for loop to do the counting or to do the addition, whereby we do the same. There, my dear students and the rest of the learners, I would kindly request that you go through the part in this series where I discussed about how the for loop works, so that you can be able to know how each of these alterations or iterations will work. Simply, this statement here means initialize the value of I to 0. Initialize the memory location called I to 0. Then check whether the value of I is less than 7. If it is, then pick the content of memory location called exams, and the content of that is memory location called exams subscript I, and the content of memory location called cards subscript I. The sum of the two, divide by 2 and assign the results to the memory location called averages at subscript I. Then increment the value of I. Check the condition whether I is less than 7. If yes, move on and repeat this operation, computing each exam and its cut average until the value of I, or the content of memory location called I, is no longer less than 7. And anytime this statement picks the value of memory location called exams at subscript I, adds to the content of memory location called cards at subscript I, and assigns the value to the memory location called averages subscript I. Once that is done, the next statement is to compute students' total marks by picking the content of memory location called averages at subscript I, you add to the content of memory location called sum, and the overall score, you add it to sum, or you assign it to sum. And then you repeat, you find out whether or you increment the value of I. If I is less than 7, do the same. Pick the content of memory location called exams at that subscript I. Then add to the cut at subscript I. The results assigned to averages at subscript I. Then pick the content of memory location called averages at that subscript I, and to the content of memory location called sum, and the overall result assigned to sum. So this iteration will repeat until all the cut and exams have been added together. And then once the value of I is no longer less than 7, we exit the loop. And then we compute the average for the student by picking the content of memory location called sum, divide by 7, and store the results in the memory location called mean score. And then we now display the performance, so performance averages. We use for loop to output each of the averages by using the for loop as usual, and just as I've explained. We format the averages, the totals displayed, into 7 characters, with 2 of them being reserved for the decimal point. So this section, or this function, or this execution, or this iteration will continue until the value of I is no longer less than total. And by that time, all the averages will have been displayed. And then we display that brace, and we drop down 1 character for 1 line below. We drop 1 line below, and then we display this statement. This student's total score is, we pick the content of memory location called sum. We formatted 7 characters, but 2 reserved for the decimal point. We display it at that position where we have %7.2 LF, meaning it is, the content is of type double, formatted to 7 characters, with the 2 of them being reserved for the decimal point. Whose mean score is, we pick the content of memory called mean score. We formatted 7 characters as we display the results, with the 2 being reserved for the decimal point. And then we return control back to the operating system, and we end our program. Let's now look at multidimensional array, or what we call 3D. The following Pascal program is used to calculate each student's performance and the class mean score, given that each student sits for a certain number of tests in a given number of subjects. So we have this as our comment. Minimum number of students allowed are 5, maximum number of students are 6, and maximum number of tests are 3. Our program is called averages. We use uses because we are going to use the function for clearing the screen or manipulating the screen. That is uses CRT. And then we declare our variables I, j, k, sum of type integer. Then we also have student num, subject num, test num, integer. Test score, class mean, class total, type real. Max as an array with 3 subscripts. That's a 3-dimensional array, with the first subscript being element 1 to 5. Second subscript is 1 to 6. That one is 1 to 3. All of them are of type integer. We have the next declaration for an array called average, which is 2-dimensional, with subscript 1 to 5 and 1 to 6. And the content is of type real. And then we clear the screen, we request the user to enter number of students within the value entered, and we assign it in the memory location called student num. Then we request the student to enter the number of subjects we read the subject, the number or the value entered, and we store it in the memory location called subject num. We then request the student to enter the number of subjects per number of tests per subject within the value entered, and we store it in memory location called test num. Then we drop down one blank, or we write out one empty line. And then we display the message, enter the marks for the student. Then we say for I equals to 1 to the maximum number entered. So initialize the value of I with 1, 2. So this is a for loop that increments upwards with 1. So when I is 1, we write out student 1. Then we enter the subject number. So for j equals 1, so we initialize j with 1, 2, the subject or the value entered and stored in subject num, do. We begin. So we display subject. If the value of j is 1, it will be subject 1. So then what about the specific value? For k equals to 1, so we assign 1 to k. 2, test num, the value stored in memory location called test num, do. So we begin. We display the statement test. So we pick the content of memory location called k. In this case, for example, it will be test 1. So we read the marks. We read the value for the score, and then we assign it to the subscript that represents student number 1, subject 1, and that will be test number 1. And that will repeat. So this for loop will repeat until we have entered all the marks for all the students. And then this statement for I equals to 1 to student num, do. For j equals to 1 to subject num, do. Begin. We initialize the memory location called sum to 0. And then we say for 1 assigned to k, or for k equals to 1 to test num, do. In other words, when from beginning with k containing value 1 to the maximum number entered as the number of tests, do. Begin. Compute the mark stored in subscript I, j, k. Pick that value stored in that array, 3-dimensional array, at subscript I, j, k, and to the content of memory location called sum, and the overall score assigned it to the memory location called sum. Then increment the value of I, the value of j, etc., and continue that loop until all the marks or all the sum has been computed for each student. And then compute the average for that student, the average for each student. How? By saying sum divided by the number of subjects, the total in memory location called sum, divided by the content of memory location called subject num. What we get, we assign to the memory location called average as subscript I for the row and j for the column. Then we add, and we add our main for loop. We clear the screen. Then we display each student's performance per subject and overall total is. So we have the headings, subject and average, spaced or formatted. Character 20 for subject, character 10 for average. In other words, from we format on the screen, we format subject to occupy 20 characters and the average to occupy a maximum of 10 spaces or characters on the screen. 10 spaces, subject to occupy maximum of 20 spaces, average to occupy maximum of 10 spaces. So we initialize our class total to 0, and then we use for loop to compute. As usual, we initialize when I is equals to 1, we initialize total score to 0. And then we display student 1. Then For j equals to 1 to subject num, do, begin, write line. Format what we are going to display to 10 spaces. Then j to 80 spaces. Average to 3 spaces. In other words, we pick the content of memory location called average as subscript I and j. We write it out. We format that value to 8 characters, with the 2 of them being reserved for the decimal point. Then we calculate the total score by adding the content of memory location called average as subscript I and j. We pick that value, we add it to total score, we assign the overall score to the total score. And that will continue, the iteration will continue until we are through with the subjects. And then we move on until we are through with the subject numbers or student number. In other words, until we are through with the subjects and until we are through with computing the total for each student for all the students. And then we end the loop. So we display, after computing the total, the overall total for each student, we display the overall total for that student. So the student has an average total of, we pick the content of memory location called total score. We display it on the screen, formatted 8 characters with 2 of them being reserved for the decimal point. So that will take place. We also compute the class total by picking the content of memory location called class or total score. We add to the content of memory location called class total. We assign the average or the sum. We assign the total. We assign the total or the results to the memory location called class total. So that will happen after every student totals have been computed. We display out the total for that student, and also we compute the class total. And then we end that loop. Then before we exit the overall for loop, we calculate the class mean. We calculate the class mean by picking the content of memory location called student num and the content of the memory location called class total. So we pick the content of memory location called class total. We divide by the content of memory location called student num. The results we get, we assign them in the memory location called class mean. So we display the overall class mean is, we pick the content of memory location called the class mean, we format it to 8 characters, 2 of them being reserved to the decimal point. And then we read out and blank, or we read nothing. In other words, this statement will pause so that we can be able to see our results, and then the program ends. So how do we pass arrays to functions? To pass an array argument to a function, specify the name of the array without any brackets. For example, if an array score has been defined as int score 5, the function called find average score 5 passes array score and its size to a function called find average. The size of an array is passed to a function so that the function can process the proper number of elements. C automatically passes arrays to functions by reference. The name of the array evaluates to the first element of the array. Because the starting address of the array is passed, the function knows precisely where the array is stored. Therefore, when the call function modifies array elements in its function body, it's modifying the actual elements of the array in their total or in their original memory locations. Although entire arrays are passed by reference, individual array elements are passed by value exactly as simple variables are. In other words, as scalars. To pass an element of an array to a function, use a subscripted name of the array element as an argument in the function call. For a function to receive an array through a function call, the function's parameter list must specify that an array will be received. For example, the function header for the function is called subscript 5 might be written as float, find average. Then we enclose int score, that is the array called score, comma, int size in the parentheses. So in the same way that we usually define the normal functions, we also do the same with functions receiving array elements. The only difference is that our parameters are of array type, like score is a parameter which is an array of type int, indicating that find average expects to receive an array of integers in parameter score and the number of the array elements in parameter size. The size of an array is not required between the array brackets. If it's included, the compiler checks that it's greater than 0, then ignores it. You can use a different name for the array in the parameter list, for example, B. And because arrays are automatically passed by reference, when the call function uses the array name B, it will be referring to the array in the caller, that is array score in the preceding call. If you don't want any function to modify array elements, you can use the qualifier const to prevent modification of array values in a function. When an array element is preceded by the const qualifier, the array elements become constant in the function body, and any attempt to modify an element of the array in the function's body results in a compile time error. The array is written in the parameter list as const int score. Once modification errors are displayed, you have to correct the function by avoiding changes to array elements. The following is a sample C program that demonstrates how to pass an array. The program passes an array to a function, which then computes the average of the array elements. My dear students and the rest of the learners, here is the program. It is important to remember what we talked about, functions, and how you pass parameters or arguments to functions, and how we declare parameters. So hash include str.h, we define our size. So constant is size, or constant is called size, and it is going to hold 5. Then this is our first array declaration. It is of type int, and this is a function. This, I repeat, this statement is a prototype. It is a prototype for a function called input scores that is going to receive one of its parameters being an array. It is going to receive an array of type int. And it is also going to have another parameter called int. So this function called input scores, this void function called input scores has 2 parameters. One parameter is of type array, that is type int, array of type int, and the other one is of type int. Then this other one is another function prototype, which is going to return a value of type float. This function is called find average. It is going to receive one parameter being an array of type int, and the other parameter will not be an array, but it will be an int or an integer. Then this other one is a function called display average. It is a void function by the name display average. It is going to receive one parameter whose content will be of type float. So those are the 3 prototypes. Then we have our main function, which is declaring an array called scores of size 5. Then we declare a variable called average of type float. We have an array, or this is a call statement. This is a call statement to a function called input scores, a void function called input scores that is going to pass scores, that is an argument which is type array, and size, the content of memory location called size. So this is an a call statement, a call to a function called input scores that is going to pass two parameters or two arguments. One argument being the array called scores, and the other one being size. Then this other one is a call statement to a function that is supposed to return a value of type float. So this function, this is a call statement to a function called find average. It is calling the function or invoking the function called find average and passing to it two parameters. One parameter is an array of type int, that is array called scores, and the content of memory location called size. When these parameters are passed to the function called find average, that function is going to return a value, and that value will be of type float. That value will be assigned to memory location called average. Then this other one is a call statement to a function, a void function called display average. This statement or this call statement is passing one parameter to the function called average or display average. It is passing one function. I repeat, this is a call statement to a function called display average, which is a void function. This call statement is passing one parameter called, or one argument to the function called display average. So it is passing the content of memory location called average to the function called display average, which is not expected to return any value because it is a void function. So our main function consists of the call statements to various functions, and it is also declaring an array called scores and a variable called average. So once that is done, we have returned 0, which tells the compiler, or which requests the processor to return back, or which informs the compiler to return the control back to the operating system. And then we have the end indicator there, the right braces. So because we have already declared our prototypes, up there, then the definitions for those prototypes are after the main. So the first function is input scores. It is receiving an array of type int by the name scores and size. I explained about functions in my previous presentations, and therefore here, my dear students, what is important for you to know what each function is going to do. So void input scores is going to be used to read the 5 values into the array. So when I is 1, it will read the first score. Increment I with 1, it will become 2. So it will read the next value, assign it to subscript 2. Continue, assign the next score to subscript 3. Assign to the next to subscript 4. Assign the next to subscript 5 until the value of I is no longer less than 5. So is 5 less than 5? No. So we are going to stop reading the values. That will be the end of that function for input scores. So this function called input scores, its work is to read 5 scores and store each in the array called scores at its respective subscript. And then the other function is find average. This function called average is having 2 parameters. One is a parameter for the array called scores of type int, and the other parameter is for size. So this function is expected to return a value, the average of type float. So we have 2 local parameter or local variables declared. We have int I, and then this statement is declaring a local variable called sum and initializing its content to 0. Then we have a local variable called average, which is going to store value of type float. And then the for loop is then supposed to do the computation or the looping. The first is to compute the first average. So this statement means pick the content of memory location called size, divide that by 2, and it. In other words, this statement reads as sum equals to what is in bracket here is simply like saying sum or average equals to bracket sum plus sum, or in other words, let me put it properly. This statement, the one which is enclosed in brackets, in parentheses, that is sum plus equals to scores, simply means and the content of memory location called score as subscript I to the content of memory location called sum. Then store what you get to the memory location called sum. So it's like saying sum equals to sum plus scores subscript I. What you get, divide by 5. Divide by 5. And store that in memory location called average. So in other words, this statement can read in full. Average equals to, opening parentheses, sum equals to sum plus scores square bracket I divided by size. So this loop here will do the addition for the scores, compute the average and the overall averages, and that process of adding or computing sum, dividing by size, and assigning the value in the memory location called average will continue until the value of I is not less than size, or the content of memory location called size. And then at the end of the day, this function will have computed the overall average. So it will return average to the calling statement of the caller. It will return average as float, and it will assign it to the respective variable in the main function. And then this other function here is for displaying the averages. So this function, just as I've said, is a void function. It will not return any value, but it is receiving one parameter called average. So it will display the average for the values entered. That is the content of memory location called average, formatted to 5 characters, with 2 of them being reserved for the decimal point. It will display that, and that will be the end of that program. And with that, we have come to the end of section 4 in this tutorial. My dear students and the rest of the learners, you can now continue to section 5 of 13 in this topic so that you can learn about the next data structure. Congratulations for learning section 4 of 13 in the topic data structures. You can also access section 1 to 13 of this topic, other topics in the computer structure and programming unit, as well as other computer or ICT videos by clicking or tapping on EMELISWAP ICT YouTube channel below this video. You can also visit EMELISWAP Life Skills YouTube channel for free life skills, motivational, and inspirational resources. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write to us through the email emeliswap@gmail.com. Thank you very much for listening to me, and God bless.